Here we have a SAT math problem. Okay, let's go to the question. The figure above shows three isosceles right triangle with sides of length 4, A and 25 respectively. If points A, B and C lie on line L, what is the value of A? Okay, in the given figure, we have to get the value of this constant A. And each of these three right triangles is an isosceles right triangle. Okay, now let me consider the first right triangle we have over here. In this right triangle, this is hypotenuse because it is opposite to the right angle. Okay, since it's an isosceles right triangle, the remaining two legs must be equal in length. We know the length of this leg, that is 4. Then the length of this leg also must be 4 because it is an isosceles right triangle. The same thing we can consider for this right triangle as well. So it's an isosceles right triangle, then the length of this leg has to be A. And in this isosceles right triangle, the length of this leg must be 25. Okay, here we can consider the three vertical line segments over here. This one, and this one. All of them are perpendicular to the same horizontal line we have over here. Since all these three vertical line segments are perpendicular to the same horizontal line, we can consider these three vertical line segments are parallel. Okay, now let me draw an horizontal line segment over here, and also let me draw another horizontal line segment we have over here, and say this horizontal line segment over here is perpendicular to this one and perpendicular to this one, and also this horizontal line segment is parallel to this one, and this horizontal line segment over here is parallel to this one. Okay, now let's consider the quadrilateral we have over here, that is four-sided polygon. In this quadrilateral, opposite sides are parallel. And also here we have a right angle at the vertex here and here. Since opposite sides are parallel and we have a right angle at the vertex, we can consider this quadrilateral as a rectangle. So since it's a rectangle, opposite sides are parallel and also equal in length. So whatever length we have for this side of the rectangle, the same length we have for the opposite sides. So the length of this line segment is 4. And here, what is the length of this line segment? So that is A, because the length of the opposite side is A. And this one also is a rectangle because opposite sides are parallel and we have right angle at the vertex over here and here. Okay, already we know the length of this vertical line segment, that is A. And we know the length of this line segment, that is 4, because its opposite side is having the length 4. So this is 4 and the complete length is A. Okay, then what is the length of this small line segment over here? For that, we have to subtract the length of this line segment from the length of the complete vertical line segment A. When I subtract this 4 from this A, I am getting A negative 4. So the A negative 4 is the length of the small vertical line segment over here. Now, let's get the length of this small vertical line segment over here. For that, we have to consider the length of this line segment, that is A, because the opposite side is having the length A. So the length of this part is A and the length of this complete vertical line segment is 25. Now, to get the length of this small vertical line segment over here, what I have to do is I have to subtract the length of this part A from the complete length 25. That is 25 negative A is the length of this small vertical line segment. Okay, now what I'm going to do is I'm going to get the slope of this line segment AB over here using the formula rise over run. Okay, now let me write the stuff over here. Slope of the line segment AB equals to rise over run. Okay, here the rise is given by the length of this small vertical line segment over here, that is A negative 4. We can plug in A negative 4 for rise, and for run, we can consider the length of the horizontal line segment over here, that is 4. And also the slope of this AB will be positive because it's a rising line segment. Okay, now let me get the slope of the line segment BC over here. Let me write the stuff over here. Slope of the line segment BC equals to, so the same formula, that is rise over run. Okay, so here rise is given by the length of the small vertical line segment over here, that is 25 negative A. And the run is given by the length of the horizontal line segment we have over here, that is A. We can plug in A for run. Actually, this line segment AB and BC, we have on the same line L. Since we have these two line segments AB and BC on the same line L, the slope of the line segment AB, the slope of line segment BC must be equal. So we can equate them. That is A negative 4 over 4 equals to 25 negative A over A. Now we have to solve for A in this equation. For that, we can do cross multiplication. That is, a numerator over here has to be multiplied by this denominator, and this numerator has to be multiplied by this denominator. Then I'm getting A times A negative 4 equals to 4 times 25 negative a. Now we can distribute this a to this a and negative 4. Then I am getting a square negative 4a. On the right side, when I distribute this 4 to this 25 and negative a, I am getting 100 negative 4a. Okay, here on both sides of this equation, we find negative 4a. To get of this negative 4a on both sides, we can add 4a to both sides of this equation. Let me do it. Then this negative 4a, positive 4a will cancel out. The same here. We get a square on the left side, we get 100 on the right side. Now to solve for a, we have to get of the square over here. For that, we have to take square root on both sides of this equation. And here the square root and square will cancel out. I am getting a on the left side. When we take square root on both sides of an equation, for the square root we have over here, we consider positive or negative sign. When I consider positive or negative sign for this square root, I'll be getting two values for a. One is positive and other one is negative. Actually, a represents the length of the line segment we have over here. So the length of a line segment can never be a negative value. So this a cannot have a negative value. So a always has to be positive. So we can consider only positive sign for the square root. And the square root of 100 is 10. Okay, here I got the value of a. The value of a is 10.